Hello, Mr. Ferrante here, and here's a quick tutorial on printf. So I want you to think about printf as an insertion print command. For example, you've got some sort of string, blah, 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 and outside that string you have a list of parameters. Maybe the first parameter I have is pi 3.14. Maybe you have character h, and then maybe you have someone's name, like here's my name. And what printf does is you can insert each of these pieces of information into the string at a certain marker. So I might insert pi in that location. I might insert this character h into that location. And then maybe I insert my name into this location. And so that's what printf does. It inserts some parameters into a string for you. And it's much better than println in my opinion. So here is the basic syntax. So you type in some sort of string as the basis of the sentence. So here's our string example. And everything else is a list of parameters to insert into the string. So in this example, I've got %f means insert a floating point number. That's any decimal. So here's 3.14 will be inserted there. %c means insert, let's go with the green, insert a character, and so that would insert this character in that position. And then finally, we'll go with purple. %s means insert a string, in this case Bob gets inserted right there. And so the output would be, you would see 3.14, a space, and then the character a space, and then Bob the string. So here's another example. When I say printf, I want more %d, more %s, that means take this integer, %d is the tag for integer, and insert this into the string right there. And then apples, let's go with green, %s, insert this string right there. So I'm going to show you one example, and after this example, I think you'll agree that printf is a lot easier than println in many situations. So here's my example. Let's suppose we have some coordinates, x is 5 and y is 4, and all we want to do is print out this this string here, point whatever is at 5 comma 4, but make sure that the 5 and the 4 are based on the variables, not hard-coded. So to do that with println, here's what you do. Here is blue jay. So here's a solution in println. So system.out.println, and I wanted to print out point is whatever. So point is, and start some parentheses, plus x, there's my 5, and then plus comma, and then plus y, and then plus the end of the coordinate parentheses, and the print line, and done. So let me compile this and run it and make sure it works. I think it will, but let's just make sure. All right, run. So yes, it is working, and we've got our output is correct. Point is 5.4, so I've attached this string to a variable, attached that to a comma, attached that to a variable, and finally close the parentheses. That's a lot of additions you can get rid of with printf. So here's the same thing but using printf. System.out.printf, and then just literally type in xy and you're almost done. So here's the format of the string I want to enter, right? Actually, let's put point is. So point is xy. Now in place of x, I want to put an integer, so I'm going to put %d. In place of y, I want to put an integer, so %d. And now outside the string, you list the parameters to insert. So I want x on the first %d, and then y as the second argument right here. And these always go in the same order in which you put them into the format string. So this will do the same thing as the first println statement, but the format is a lot easier to print with an R. The format's just easier to type in my opinion. You save yourself from doing these extra plus symbols all over the place. Instead, you write what you want directly and simply replace certain markers with % whatever, and those get inserted afterwards. So let's compile this, run it, make sure it works. Okay, run. So here's the output window, and yes, we have the same output, top and bottom. Oh, sorry, I put print instead of point, but yes, same thing. Anyway, print line's working and it's a lot easier. So here, point. So I hope my point is clear. Printf is a lot simpler when you just need to build up a complex string but insert information in certain spots. Okay, next up on the PowerPoint, here is the kind of summary of the printf syntax. There's a lot more to it. Check out the Formatter API if you want to see more, but to start with for our class, this is all you need. So let's discuss some of the other features of printf besides just printing certain data types. And down here in the corner is a list of all the data types you actually need for our class. So like you saw in the demos, %d means insert any kind of integer, long or int. %f means insert any kind of floating point number, so double or float works for both. %b for booleans, true or false. %f for strings, and %c for characters. Those should be the only data types that you actually need. Now let's talk about the flag. So here's the printf syntax. You put %, you've seen that. You've also seen the conversion tag. So these two things you've seen, % and whatever. But now let's look at the flags right here. So flags, the ones you need are these three. And let's first focus on the dash symbol. So think of printf as a spreadsheet, actually. Let me draw this out for you. So if you were in Google Sheets or Microsoft Excel, then what you would see is this. You'd have column A, you'd have column B, and you have column C. And each of these columns you can print information, but they have a certain width, right? And they have a certain justification. So if I were to print high, it might be left justified in column A like you see right here. Or maybe column B is right justified, and so if I printed high, it would be way off to this side. And maybe column C is centered. So with using printf right here, if you don't put any tag, your information will be right justified in a certain field width. The width of the field is how wide, it's how many characters wide you have to work with. And so this would be the field width that I'm drawing with arrows right here. So we need to work with field width and flags at the same time. If you put a dash, then remember you put it after the %. So after %, if you put a dash flag, your text will be left justified in its own field. So let's try this out and you'll see what I'm talking about. So back here, let's get rid of the first line here. All right, let's say that we want this to be left justified, so dash, in a field width of 5. And the other, the y coordinate, just, I want a field width of 5. Actually, let's do 10. And since I don't want it left justified, if I put nothing here, which is what I have, it'll be right justified. A dash is left and nothing is right. So let's compile and run this and see what we get. All right, here's the output window. Here's the code. So it's working just like a spreadsheet. So what we have is, you see %-5d. That means right here is column A, and you have 5 spaces to work with. So this was 1, 2, 3, 4, 5 spaces here. Then there was a comma because of that comma we put in there, a space, and then %10d means there's 10 spaces here total. 1, 2, 3, 4, 5, 6, 7, 8, 9, and the 4 filled up the 10. So this column or field was 10 spaces wide, and the 4 was right justified in there. So point being, you can insert a little dash after the % symbol to left justify your information. And you can specify in the width category how wide you want the information to be for its column. And precision we'll do in just a second. All right, let's still talk about width. If there's not enough space for width, then Java will just fill the space up. For example, let's say I go and try, let me get to my code. Let's say that these numbers are large, like this is a big coordinate, and that's also a kind of big coordinate. It's both something not so big there. So this is clearly more than 5 characters wide. If I try to print it in a space of 5, Java can't fit this in a space of 5, so it's just going to expand the width until it does fit. So in this case, the width is 1, 2, 3, 4, 5, 6, 7. So Java is going to automatically do a field width of 7 to make it fit, even if I put something smaller like 3. In this case, this will already fit inside a field width of 10, so there's nothing to update there. All right, so let's try this out. So compile this, run it, make sure it's doing what we want. All right, back to the code. So here you go. It tried to fit this in a field width of 3, but it doesn't fit, and therefore Java expanded the field width to the full number width. This was a field width of 10, and that this is 10, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I counted exactly, it would be 10 from right. Actually, there's a space right here, so ignore the space. Everything else is 10 characters wide after the space. So our field widths are working just fine. All right, the final thing we haven't discussed yet is the precision. So precision does two different things. If you have a numerical type, then the precision is going to round to the given number of decimals. If you have a string, then it's going to truncate the characters down to that many. So we're going to try both, and it's not allowed, you can't use precision with anything else. It only applies to strings and to decimals. So let's try decimals first and then move on to strings. All right, back to our code. So since I need some decimals, let's make these coordinates doubles. So double x and double y. And let's say this is 5.6789, and this one is 1.0123. Good enough. All right. Now if we go and print these things, these are now doubles, so I need to update this from D to F for floating point number. The field widths can stay the same, doesn't really matter. Remember, 3 doesn't fit the number, but it'll just shove it in place. But what I can add is I can add the precision. So 3 point, let's say 2, that should print this to 2 decimal places and round it. So this 0.8 at the end is going to round this 7 to also an 8. And then how about 10.0? That will round this to no decimal places. Just try it out. So let's compile this and run it and see what we get. Okay, run. And let me find our code. So here's what we're getting. We're getting exactly what we asked for. So field width of 3 and truncating to 2 decimal places. That's what we have exactly. Although it's not 3, the field width is 4 because we've got 1, the decimal takes up a spot for the column. So 1, 2, 3, 4. It's actually 4 wide because it couldn't fit in 3. I can prove to you this is actually 4 wide because if I put 5 here, we should get 1 extra space in this. So let's try that and make sure that actually works. Recompile, rerun, and here's our updated output. And yeah, perfect. So remember, this dash means left justified. So what we're getting is in a field width of 5, we're getting 2 decimal places of this x floating point number. So Java has inserted x into this location, or right here, and it's a field width of 5. Here's the 5, watch. I'll show you with the cursor. 1, 2, 3, 4, 5. It's left justified because of the dash. You can see it's left justified here, and it's a 2 decimal precision, 0.68, and finally it's a floating point number. That's why we have decimals. And the other one we had a space of 10 rounded to 0 places, and that's what you get. So here, I'll count it off. Here's, oh, I can't. Here we go. I can highlight this way. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's the field width of 10. And the 11th thing is for the space that's actually right here. There's a space just kind of between these two things. But the 10 right here is what I have highlighted here. So, and it's right justified because if you don't put anything, no dash, it's going to be right justified by default. So That is precision for decimals. With strings, it's the same thing except for it truncates the string. So here's an example. String name equals Harry. And if I put, let's name this point Harry, so point %s. Now we're going to insert name right there, but we want to print Harry point 2. So if you just start with point whatever, that's the precision, and that means truncate this to only the first two characters. So it should print only HA. So we'll try that out real quick. And yeah, perfect. So here's the code and the output. So point HA, because we've truncated this string to 2 decimal places, 2 character places, and everything else is chopped off. Now, of course, what would happen if I did this? If I said 5.2, that would mean use a space or field width of 5, but only use 2 characters, and would it be left or right justified? That's correct. Without a dash here in front, it's going to be right justified. So if I run this, what I should expect is a field width of 5 spaces, only use 2 of them for the HA, we should get HA off to the side, and we should have 3 spaces in front. That would account for our 5 spaces total. So let's run it and see if we get exactly that. All right, compile, run, and here it goes. So here's my output, here's my code, and perfect. So we've got point, here's the 1, 1, 2, 3, 4, 5. That's exactly what we've got. The space after T is simply because I put a space right there, right here. Everything else after that was our 5.2 was this region right here. So it's working perfectly. And the only thing on here I didn't discuss yet is the comma. Remember, it's a flag, so it goes right here after the percent symbol. If you put a comma in the flag region, you're going to get commas inserted into numbers. It's very cool. So check this out. In my very large, let's go back to integers. So if I had large integers, then I could automatically insert commas into the integer for us. So there's one. Let's just say this is that number there. And remember, this needs to be changed back to D because now they're integers. And you can't truncate, so take that out. If you leave it in, it'll be a compiler, it'll be a runtime error. Java will complain when it runs. And the formatting doesn't really matter, let's go 5 and 5. But check this out. Put a comma inside the flags region, which is, it follows the percent immediately. So here, after the percent, put a comma, and then check it out. Compile, run this puppy, and here's the output. Here's the output, here's the code, and you can see that Java inserted for me commas into my number. So here's the first number with commas inserted, and here's the second coordinate with commas inserted automatically for us. Now the commas count as part of the field width. So when I said field width of 5, it includes the comma. So we've got 1, 2, 3, 4, 5. And remember, this extra space right here, is coming from the fact that I put a space right there as part of the string. So that is a quick summary of printf. I guess there's one more page, and well, I'll go ahead and do it. If what we've done so far is enough for you, you can stop the video, but I'm going to explain one more thing, which is pretty awesome and it's quite powerful, and that is you can customize the field width and have it be a variable itself. So for example, here in my code, I said that 5 was the field width, but what if you want the field width to be a variable and it can change? So instead of hard coding 5, I want some sort of custom field width. So integer width equals, let's say it's 10. Now remember, since this is a variable, I could change this, or it could be in a loop, and it could be changing every time I print something. So in fact, let's do that. This is actually be a better situation. So let's do a for loop for int, actually let's go w equals, let's go with 3, while w is up to 10, So if you're new to Java this year, this is a loop that's going to repeat code, and W is a variable that ranges from 3 to 10. So this code will run, and the first time it runs, W will be 3. It's going to run this body. It's going to go back to the top. It's going to run it again with W equals 4. Then it's going to keep running with W equals 5, 6, 7, 8, 9, 10. So this loop runs over and over again with the values of 3 to 4 to 5 up to 10. And so inside, I want to print a random, not random, but I want to print out W as my field width. So let's do a simpler output string. Let's do systemout.println, actually, sorry, printf. And let's just print the x coordinate by itself. So there's that. Okay, printf. But for my field width, instead of hard coding something like a field width of 5, I want to put a field width of W. Now if I just do this, that's not going to work because I've just hard coded W as a format specifier, but nowhere on a PowerPoint does it say that W is a kind of conversion tag. So that will be an error. So there is no W conversion tag, so forget that. Instead, you need to make sure it's %d, but for the width, you can build it up. So check this out. Plus W plus D. And now I've inserted W as a variable, attached it to the percent, so it's basically percent whatever W is, and then D. So this is a way to get variable field width, which can be very powerful depending on what you're doing. So it compiles, and if I run it, let's get back to running. Okay, let me put a print line at the end. It's all in one line, which is not very useful. So /n, remember /n means new line. It's the same as doing print line. And so that will give us a line return after each line. Okay, try it again. So here's what we got. And here is the code. So this loop's running with a field with a 3. Remember, since it couldn't fit this number into a fit the 3, it is expanding it to fit. So we had 3, 4, field width of 5, field width of 6, 7, and finally there's a field width of 8, field width of 9, and a field width of 10, which means there's 10 characters total from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's a way to get variable field width, and that's the last thing that I'll say about printf. So have a great day. I think that'll make the reading a lot easier since this is visual. Have a great day. See you in class.